Hey, I'm Chris Zepp from Make Everything, and today we're gonna fix this broken post vise. Check it out. All right, here's the story with this thing. Last year I was up at Jimmy's house and I asked him about a post vise. He said, I've got one in the back. The threads are shot. If you want it, try and fix it. It's yours. So thanks so much, Jimmy. I took it home, started messing around with it, and here's the issue. The problem here is that the threads on the screw and the threads inside of the nut are totally stripped out. I thought of a bunch of ways to try and fix it, and none of them are really gonna work. So I went out and I got some Acme screw from McMaster Car, and this is what we're gonna use to do the repair. So to start it off, let's get this thing apart and get moving. Okay, so take a look at these threads. Now they should look like that. Also, it's going to be hard to see, but inside there's pretty much no meat left. So my plan is to replace this with this and get this guy to fit inside there. And that's going to require going over to the lathe and getting some work done. All right, so this project starts over at the lathe. I took that tail piece and I chucked it into the 3-jaw chuck. Now it is round on the backside, but it's not really round enough to do any real work on. So I go ahead and I grab the magnetic based indicator, and this measures to 1/10 of 1,000. So if you see that needle moving around a lot, that doesn't necessarily mean it's that far out around. And here I just sort of knock it into place. The 3-jaw chuck is kind of tight, but not tight enough that it's going to keep it locked in, and that allows me to just sort of get it well within the range that I can turn it round. And I'm going to grab a boring bar and a steady rest, and I'm going to basically just be blasting out whatever's left of the threads inside this thing. The steady rest is going to keep this from flying out and hitting me in the face. It was a little sketchy to have it in that 3-jaw chuck, not really knowing how it was going to react and if maybe it was going to slip. So that definitely put my mind at ease. And then the boring bar operation is pretty straightforward. I kind of took shallower passes than I maybe could have, but I didn't really want to break the boring bar because I was borrowing it from a friend to begin with. More or less, I'm just trying to clear this out and make it anything close to round that I can. In the end, I'm going to be trying to slip the coupler nut that I bought in there, so the more surface area I can get by removing threads, the better. Now once I got those threads knocked out of there, I could go ahead and measure the inside and then use that number on the coupler nut to get an idea of how much I need to turn down. Anytime I turn down any sort of octagonal part like this, I want to take off the corners if I can, and what that is going to allow me to do is just get a little bit better of a cut from my cutters without having so much of an aggressive edge hitting them. Now these are just sort of cheap carbide cutters from Amazon, so I really didn't want to push them too hard. Now, I'm by no means a machinist. I've said this in many of my videos before. Using the lathe, I'm not great with accuracy, but I had an idea of where I needed to go, so I basically just indicated against it with the calipers, and I was able to sort of check it as I went to make sure that I would get a nice friction fit inside that tailpiece. Surface finish wasn't super important on this. It basically just had to fit tight enough that I could bang it in. Now I thought of a couple of ways to keep this coupler nut inside the tailpiece, but heating it up seemed problematic, and I didn't have a press or any way to put it in a vise, so I just decided to bang it in with a mallet. I knew this would round over some of the threads, but I wasn't super worried about it because I knew that the coupler nut would bottom out before I reached the edge of the existing material. Now obviously I did wind up rounding over those threads, but it's no big deal. I just run over to the bandsaw and cut them off.
All right, so I've got the Acme nut hammered in there. It is not going anywhere. This thing is hot just from the friction of that going in there. Now I want to try the Acme thread in there, but there's some shavings in there. I want to blow those out and give it a shot. Look at that.
So now that I got those threads working, I'm able to start working on the other side and start working on the male section of it. So I cut off that handle, and I'll be able to put that ball finial back on once I'm done. And then I bring the actual bolt over to the bandsaw and cut it off. Now this ball section, I thought a lot about how I was going to attach the new Acme thread to the ball section, and what I decided to do was bore out a hole in it and then turn down the actual Acme thread so that it would fit in like a male and female section that I could weld back on to get a really nice amount of surface contact. Again, I took the indicator just to make this thing spin as round as I possibly could, and I'm going to start off with a facing operation just to give myself a nice reference for drilling this hole. Now the finish on this also was not super important. This is going to get drilled out and welded to, but I did want to have something nice and flat that I could use a center drill on to get this whole thing running a little bit smoother. I took my tool rest off completely for this drilling op because I knew it was going to be a little hairy. I started with the biggest center drill I had, and then I stepped up to a 1/2 inch drill bit. I wound up drilling about 1.5 inches into that ball end, and that was just shy of popping out where the handle would be. Now I wanted to drill this out, and my goal size on this was around 15/16, close to 7/8, sort of whatever I could do. Now the 15/16 size, I didn't have a drill bit for that, so what I wound up using was a 2-flute end mill. This isn't really recommended, and you can tell I had a ton of chatter on this. The other problem I had was I didn't have a chuck that could hold it for the lathe, so I have a chuck within a chuck. I'm holding it with my hand to try and stabilize it, but all in all, the material drilled well enough. The surface finish on the inside of this hole was absolutely horrible, but it's okay. For what I'm doing, it's not going to matter at all.
Whoops.
Rustic look?
Yeah, dude, it worked.
But
What do you want from a 2-flute end mill?
This going in there?
Now that I got the inside of that ball all turned out, I can put the tool rest back on and take my Acme thread and start turning down the end of that. So with the hole that I put inside that ball end, the hole size wound up not being exactly 15/16, so I was sort of having to do the same thing I did on the coupler nut and turn this a little bit, check it with the calipers, and keep going back and forth until I wound up with a size that worked. I drilled 1.5 inch hole inside the ball, but I turned this at about 1.75 inches so that I would have a little bit of room that had no thread on it so that I could weld to it. And I was going for a friction fit here, so I let this sort of slide on, and I knew I had some room to go. Once again, I went over to the anvil, and I basically just bashed this thing in there. And now this thread wound up being about 4 inches longer than it needed to be, so I knew I could hit on this with the hammer, get a friction fit, and then from there I could just cut it off so that it was the correct length. I didn't really have to worry about damaging the end of those threads. Now once it was cut, I just took it over the grinder and rounded it over so it would be nice and not strip out the Acme screw. And I'm able to do basically my first test assembly of this to make sure it works. It felt really good to know that the concept that I've been thinking of for months actually worked out. Now it's just a matter of securing all of this stuff with some welds. Now I know there are going to be comments about welding this stuff with the MIG welder. I know there's a bunch of other ways I could have done this. I probably should have preheated them and I could have brazed them, but this was what I had, and I really think that it's going to turn out fine considering how tight the friction fits I got on these parts were. That nut is bashed in there like you can't believe. I can't imagine it's ever going to pull out. And on the threaded side, it's really a tight fit as well. Plus, there's so much more surface area for me to weld to. And if I ever have a problem, I could always just put a cross pin in the recess of that ball area, and this thing would never go anywhere. So I was really careful with my heat because I didn't want to crack anything, but overall I think the welds turned out fine. And then I was able to weld the handle back on by just putting that little ball finial back on the end. And once that's all grinded out, you'll never even know that it was cut off. Once that stuff had cooled down sufficiently, I took it over to the grinder and I blended everything in so that you can't even tell that there was ever new threads put inside this thing. Everything blended in super nice and it looks like it's all one piece. Same thing with the handle. I wanted to grind away those welds so this looked like it was forged back from the way it was, when this thing was originally made, probably about 100 years ago. Now it's just a matter of cleaning this thing up. There was so much surface rust on it from wherever the hell Jimmy got it, and it was been sitting in his shop on the floor for a while, so I went outside and I grabbed the trusty wire wheel. Now on my last Vise restoration, a lot of people said, oh, you should use a sandblaster, why would you use the wire wheel? The wire wheel gives a particular kind of look that I really like. I'm not a huge fan of a sandblasted look unless it's going to be painted, and this I have no intention of painting. I love the way that the wire wheel sort of leaves some highlights, but it does get rid of that rust and exposes the raw steel. The wire wheel that I'm using in this video is a cupped wire wheel from Benchmark Abrasives. They provided all the abrasives for this project to make really great stuff, and I'll talk a little bit more about them at the end. So I just sort of go ahead and try and get as much of the surface rust off as I can. And some of the parts will have to be touched up again on the bench grinder wire wheel, but I do as much as I can outside. Grabbing stuff like this in a vise, having an extra vise, that you can move around is super handy and sort of makes these operations a lot safer. You can really easily throw parts with a grinder like this, so you want to be as safe as you possibly can whenever you're doing anything like this. Now once I was done with the wire wheel, I put on a paint stripping wheel, and this just sort of brightens up some of the areas. It takes a little bit more off than the wire wheel does, and it just sort of gives some highlights to it. I did this more for sort of an aesthetic purpose on some of the parts that would be more visible on the vise. And again, inside on the bench grinder, just sort of buffing away any of the rust that I couldn't get to with the grinder wire wheel. Now on this back mounting plate, someone had cracked off the sort of leaf that was forged into it, so I decided to just cut what was still there off and grind it so that it would at least look symmetric. And then this will give me a little bit more room on the anvil that I plan on attaching this to. Now with all that work done, I can finally do a real test assembly and see the way that this thing is going to look. I put my wedges back in and make sure my spring is working. Now when I got the vise from Jimmy, it had no pivoting bolt, so I took a 3/4 inch piece of all thread and some nuts and washers, and I put those in there as well. I made sure to grease all the moving parts so that everything would move really freely, and in the end, everything was operating like it was brand new again. Now I did put some blue Loctite on that all thread just to make sure that those bolts would not come loose. The nuts on the end of that all thread would never come loose, but if I needed to take them out, I could just heat them up and pull them out. And you can see I get a nice action out of that new thread and nut. Mounting it on the bench, I get an idea of how it's going to work, and then I decide it's time to make a stand. Now I had a concept in my mind of what I wanted to do for the stand, and I actually had some scrap metal around that I could use. I'm using a 1-inch plate for what's basically going to be the mounting piece and a little anvil, and I'm using a piece of 3/8 plate for the bottom, and then the column is going to be a 2-inch by 3-inch rectangular stock with a 1/4 inch wall. All these pieces of material are super heavy, and they're all covered in paint because they basically came out of scrap piles. So I bring everything down to a nice polished sort of, raw steel finish. And then I go over and grab some die-chem so that I can lay out my bolt holes and the hardy hole that I'm going to put in this 1-inch plate. Now, to lay everything out with a calipers is really nice. You're going to get the most accurate lines that you can out of a caliper. And somebody's going to talk about how I use the caliper as a scribe, but I really don't care. It's always how I've done it, and, it's worked out pretty well for me. So I decided I wanted to put a 7/8 hardy hole in this 1-inch steel plate so I could use some of my hardy tools with the post vise, some of my bending tools and some of my hot cut tools. To start off, though, I did have to go and pre-drill through this 1-inch steel, which was a little testing. I'll be using 3/8 16 bolts to keep the post vise attached to the plate. So I start with those 3 holes and I drill them out with a 1/4 and eventually step up through the sizes until I'm at 5/16, which is enough for me to tap with a 75% thread. And for the hardy hole, it's a little bit more work. I have to drill out with the 1/4 and obviously step up with the rest of the bits, but eventually wind up at a 7/8 inch hole. Now, anytime you're drilling through a thick piece of plate like this, I've got my drill press on the slowest speed, and I'm using a lot of cutting oil just to make sure that I don't break any drill bits. The last thing I want is to try and get a broken drill bit out of that 1-inch piece of steel. The largest drill bit that I had in conventional size was a 1/2 inch, so I drill out that hardy hole with 1/2 inch, and then I step immediately up to a 7/8 inch Deming bit that I got online. Now, these were like a cheap set. It was like under $30 for a set of 5 or 6 of these Deming bits that went all the way up to 1 inch. So I didn't really want to push it super hard. I just took my time, used a lot of cutting oil, and really like a low RPM, and you'll get through even a 1-inch piece of plate steel like this. Now, in order to make the hardy hole square as it should be, I decided to go over to the milling machine. I thought of a couple different ways to do this, maybe using a file or a Dremel or a die grinder, but in the end, I felt that the milling machine was going to do the best job, but I didn't go ahead and do any sort of indicating or any real planning for this. I found a 1/4 inch carbide end mill in my junk bin of end mills, and I just sort of set up the plate and went to work. I had some scribe lines on there to reference, but in the end, the hole came out a little bit oversized and a little bit out of square. At the end of it, I really don't care. It's going to be fine. It's not going to really be used too much, but it is nice to have a square hole in this 1-inch steel plate that I can put some top tools in or maybe use for something else in the future. I did this cut in a few passes, and I wasn't actually able to make the entire cut using the end mill, so I do eventually have to take this out, grab a file, and just sort of file out those holes. But it did make it so that I was able to soften the edge and make it a little more friendly instead of something that would, mark up material or maybe break something with a shear point. Now, with the hardy hole done, it was time to tap these 3/8 holes. I thought about doing these by hand, but I do have a Tapmatic tapping head. I have never used it, though, with a 3/8 inch tap. I typically use 1/4-20s or smaller, and I use my Grizzly mill for these. So it was the first time I'd used it in the Bridgeport and on something this big. I had some problems with the taper that it attaches with. It kept popping off. So this first hole took a bunch of tries. And then the second hole, there is that little lever on the back of the Tapmatic, and what that does is it allows it to automatically reverse. But I never really thought about how much torque it was under, so I did have a little bit of a problem.
Fuck!
You can see it had so much leverage, it just ripped that clamp right off. You need to have something blocking that bar from spinning, otherwise it won't automatically reverse. I had 3 holes to tap, and by the 3rd hole, I felt like I knew exactly what I had to do to make this thing work with the 3/8 inch tap. I put in a post, and I'm going to let this one play full speed so that you can see how quickly it does this 1-inch plate. That's like 6 or 7 seconds to do a 3/8 16 tap in 1-inch plate steel. It's really an amazing tool if you do a lot of tapping. Look into getting yourself a Tapmatic head. Now that everything was threaded, I could go ahead and deburr the back and start planning to put my column in place. Now I did a quick test bolt up so that I could measure the length of the column. It was really important that this was the right length because the post vise has to sit on the ground but also be tight to that plate and not have any play. So I really wanted to make sure that I made this perfect. I did a bunch of measuring, and then I went out and grabbed the cold saw so that I could cut down the 1/4 inch wall rectangular tubing to size. Now, you could use the bandsaw for this, but the cold saw really does a much better job. The bandsaw blade has a tendency to wander in material that's this heavy, so it doesn't hurt to have one of these to make pieces like this. And I decided to cut a 45-degree gusset as well, figuring that you might be hammering on that hardy tool, so you're going to want something that can help support the weight. I just do a little bit of prep work using that cordless grinder to make sure everything was ready to weld. Now alignment is really important on this too, making sure everything is perfectly square. This piece happened to have a really nice cut on one end. It was from the factory, so it was nice and square, and I was just able to tack it in place and keep moving through it. Now on my welds, I'm concentrating my heat on that 1-inch plate. I really want to burn into the 1-inch plate and attach the 1/4 inch wall tubing. So it's important to focus your heat and set your machine really high when you're welding to a 1-inch piece of plate like this. I'm tacking everything in place again on this gusset and then just welding it all through. Now with the top plate welded on, I'm able to start working on the base section. So I made myself this little jig out of 2 pieces of 2x4s. Basically what this is going to allow me to do, is going to allow me to hold up that column and not have to worry about it toppling over on me and get it really nicely positioned. So I lay everything out with Sharpie on the plate and I clamp this thing in place so that I can take the column and clamp it to that. Now I didn't go crazy trying to make these 2x4s perfectly square because I knew I could just adjust column. A good little trick for welding is I use a razor blade as a shim here. Now a razor blade is nice because they're nice and thin. You can weld right through them and they snap off really easily because they're super brittle. So I use that razor blade and that gives me the perfect amount of shimming that I need to get this thing perfectly square in both directions. I tack everything in place and I go ahead and keep checking it to make sure it's right.
Oh, beautiful!
Once I know everything's good, I can go back in, I can break that shim off, and then I can fully weld all these pieces to the base plate. You can tell I was pretty excited at this point. Everything was working out really nicely. I wound up having the perfect height, and the only thing I wanted to add was a plate at the bottom that would hold onto that leg and just keep it from kicking out in case it ever, got a lot of force on it. So I decided to push this Deming bit as hard as I could and just drill a 7/8 hole in it without a pilot. It actually held up pretty good. It did need to be sharpened after this, but it worked out, which I was really impressed considering the bit probably cost me under $5. And now I can add the final bit of work to this. I can clean off that die-cum. I didn't want to have that red stuff on there. I had to make it look nice. So I clean the die-cum off, and then I will add that little spacer to the bottom, let the legs sit inside it, and then I can put the final bolts on the top side. Now these are just 3/8 bolts with a washer and a lock washer on top of that. Tighten them down nice, and then I can weld that little spacer in place on the floor, and it'll just keep this thing from ever moving. Now I'm not actually welding the vise to the floor because I do want it to have a little bit of a floating capability, but this will just keep it from moving around, which I think will be good. You can see there too, I drilled 4 holes in this bottom plate because my goal is that I will put drop-in anchors in the floor and I can bolt this thing down if I ever need to. Overall, I'm super happy with how this thing came out. It's so heavy and robust and it looks great. I love the raw steel look, and I'm really happy to have this little hardy hole set up. I can use some of those hardy tools and, expand the capabilities of this tool. I think it's going to be a great addition to the shop. I cannot wait to use it.
All right, that does it for this video. I had a really good time on this restoration. Got to mess with the milling machine. I got to mess with a bunch of welding. Fixing this thing was a goal that I had ever since Jimmy gave it to me back in November. And everything that I had in my head for the repair worked out, so I'm really happy with it. I can't wait to get using it along with my other blacksmithing stuff. Expect more blacksmithing videos coming soon. I want to give a special shout out to Benchmark Abrasives for providing the abrasives for this restoration, the flap discs, the wire wheels, and etc. I've been using Benchmark Abrasive stuff since long before I ever spoke to them. They sell a 10-pack of zirconium flap discs that are going to wind up costing you like $2.50 a disc, which if you've ever bought them at the store, you know that that's really, really cheap. They're a great product. There's a link in the description that if you buy through them, it helps support me and helps support the channel. So if you're interested in checking out their products, please do it through that link. Thanks so much for watching this. If you have any questions, leave them down below. If you want to see behind the scenes stuff, I posted so much about this while I was doing it on my Instagram. Follow that at Make Everything Shop. Again, I am Chris Zepp from Make Everything. Thanks again, and I hope to see you on the next video.